Assalamu alaikum, meet Ismail, an absolute technology genius.
He'll take you from basic electrical theory straight into real, hands-on builds.
Hit subscribe for weekly explainers and let's start building today.
Hey there, and welcome to this explainer. Today, we're diving into the fascinating, almost entirely invisible journey of the electrons that power modern electric scooters. It is this completely seamless process that gets you from point A to point B without using a single drop of gas. So grab a seat, because we are going to break down the incredible, hidden engineering that's happening right beneath your feet.
Think about it for a second. When you twist the throttle of a modern electric scooter, whoosh, you just fly forward. You get this instant, exhilarating speed. But how on earth does it actually pull this off? There's no traditional combustion engine, there's no complex gearbox shifting away, and there's definitely no gas tank. So where is all that raw, instant power coming from? And how is it being controlled with such amazing precision? To wrap our heads around this, here's our game plan for today. We're going to cover 6 key steps. 1. The engineless marvel. 2. Heart of the EV. 3. The scooter's electronic brain. 4. The wheel's direct muscle. 5. The magic of braking. And 6. A fully digital journey.
All right, let's jump straight into step 1, the engineless marvel, looking at the core systems. Instead of a gas tank and an exhaust pipe, every electric scooter relies on a perfectly synchronized team of 6 main systems. We've got the battery pack, the BMS, which is short for battery management system, the motor controller, the BLDC motor, the brakes, and of course, the display. Now, these aren't just isolated parts bolted together. They are a tight-knit ecosystem working flawlessly to turn raw electrical energy into instant physical speed. Moving right along to step 2, heart of the EV, focusing on power storage and safety.
You know, the journey really kicks off with the battery. But it's super important to realize that it's not just one giant, heavy battery block sitting under the floorboard. It's actually made up of hundreds of tiny, individual lithium-ion cells. And engineers do something really clever here. By wiring these little cells together in a series connection, they boost the overall voltage. Then, by wiring them in a parallel connection, they pump up the capacity. When you combine both of those methods, bam, you get that high-energy battery pack that delivers the serious range and power you need.
But honestly, the absolute unsung hero of this entire power system is the BMS, the Battery Management System. Think of it as the ultimate bodyguard for your scooter. While your wall charger is busy doing the heavy lifting of converting your home's alternating current into a stable direct current, the BMS is hyper-focused on safety. It is constantly checking the voltage, the temperature, and the current of every single individual cell in that pack. It literally ensures that nothing overheats or gets damaged, keeping the whole setup incredibly safe.
Okay, so your battery is juiced up and totally secure. Now, when you press that power button, you obviously don't get that classic engine roar kicking over, right? Instead, you get this lightning-fast, totally silent digital handshake happening over what's called a CAN bus network. The electronic systems wake up, chat with each other, and clear all their safety checks in a matter of milliseconds. Only after that invisible, high-speed conversation does the dashboard actually light up, showing you your battery level, your riding mode, speed, and system status. You are officially cleared for takeoff. With the system awake and ready to go, we reach step 3, the scooter's electronic brain, the controller. This is the exact piece of hardware that dictates just how fast you're going to go.
Think about an old-school gas scooter for a second. Twisting the throttle literally pulls a physical metal cable. But on an electric scooter, there are no traditional cables. Instead, when you twist that grip, you're actually activating a tiny little component called a Hall effect sensor. This sensor instantly fires off an electronic signal to the motor controller, basically saying exactly how much speed you're demanding. The controller then instantly does the math, calculating the precise amount of electrical power needed to make that happen. But right here, we actually hit a massive technical roadblock. See, the battery stores direct current, or DC power. However, that fancy modern traction motor sitting in your wheel absolutely demands multi-phase power to spin. So we've got a fundamental mismatch between the type of energy we have sitting in the tank, so to speak, and the type of energy the motor actually needs to move.
So how do we fix it? Well, engineers use these brilliant little components called MOSFETs. Housed deep inside the controller, these power electronics act like rapid-fire translators. They take that steady direct current from the battery and rapidly switch it, chopping it up to convert it into the exact 3-phase electrical output the motor is hungry for. They solve this huge power mismatch in fractions of a second, making sure you get a completely smooth, continuous flow of energy.
Getting that freshly translated power into physical motion brings us to step 4,
the wheel's direct muscle, the BLDC motor.
So that newly translated three-phase power flows straight into the BLDC. That stands for brushless DC motor. Inside this motor, it's basically a physics experiment on steroids. You have these tightly wound copper coils. When electricity hits them, they instantly become incredibly powerful electromagnets. Surrounding these coils is a rotor lined with super strong neodymium magnets. The changing magnetic fields in the coils violently push and pull against those neodymium magnets, and that is what rapidly drives the rotor forward.
And honestly, here is where the design gets so beautifully elegant. In most electric scooters, this motor is built directly into the rear wheel itself. There is no messy chain to oil, no rubber belt that might snap on you, and absolutely zero clunky gearboxes. It's direct drive. The spinning rotor literally is the spinning wheel, sending pure, unadulterated power straight to the pavement.
To make sure this direct muscle doesn't skip a beat, there's a non-stop conversation happening. Sensors inside the motor are constantly beaming data back to the controller. Say you hit a nasty steep hill, or maybe you're carrying a really heavy backpack. The controller senses that and automatically feeds extra current down to the motor, giving you maximum torque so you don't stall out. Oh, and since all that raw electrical current generates a massive amount of heat, the controller and the motor use specialized aluminum fins to safely shed that heat right out into the passing air.
All right, we've gone fast, but we also need to stop safely. That brings us to step 5, the magic of braking, stopping, and recharging. And this features one of the absolute coolest engineering tricks in modern transport.
Now, naturally, an electric scooter is going to have standard hydraulic disc brakes that use good old-fashioned physical friction to grab the wheels and stop you. But there is a totally hidden layer of magic here called regenerative braking. The split second you let off the throttle or gently tap the brakes, the system pulls off a wild trick. It literally flips the motor in reverse and turns it into a generator.
Let's break down exactly how fast this happens. In second 1, you release the throttle. By second 2, your forward momentum, all that kinetic energy keeping the wheel spinning, is grabbed by this generator. By second 3, it is actively converting that physical motion back into pure electricity. And by second 4, it pumps that newly created juice right back into your battery. It is a totally brilliant closed loop where you're actually recharging your scooter while you drive. You literally extend your range just by slowing down.
Finally, let's wrap this up with step 6, a fully digital journey, smart connectivity, and safety. We've watched how the power actually moves, but let's see how this entire incredible journey of the electron is governed.
Because this entire machine is fundamentally a digital system, it is packed with insanely fast safety mechanisms. If there's ever a severe short circuit or a massive spike in heat, the BMS and controller will instantly pop open emergency relays, cutting the power dead to keep you completely safe. And beyond safety, this whole digital brain connects straight to the smartphone in your pocket. You can check your battery health, track your scooter via GPS, look at your ride stats, and even download over-the-air software updates. Meaning, crazy enough, your scooter actually gets smarter the longer you own it.
So, let's zoom out for a second. From the exact chemistry happening inside those battery cells, to the rapid-fire MOSFETs in the controller, down to the violent push of magnets inside the direct drive wheel, it is just a masterclass in modern engineering. Without burning a single drop of petrol, this invisible, perfectly seamless flow of electrons powers your entire daily commute. But it leaves us with one incredibly exciting question. As this entirely digital foundation keeps evolving and getting smarter, how is it going to reshape the future of literally everything else we drive? Thanks so much for joining me on this explainer. I really hope it sparked your curiosity.